Okay, they're going to try to scare you with some Newton's law of gravitation, but remember, we're in Calculus 1, and all we're doing is derivatives, so it's probably going to be pretty much just a derivative. And I looked this problem over, and I'm pretty confident that's the case. And all they want you to understand is that if you have the Earth, I'm just going to draw one part of the Earth, and here's you. There's a distance between you, and it doesn't really matter if you're at this part or this part. All that matters is that there's a distance between you. So they call it r, like the radius for anything that's here is going to experience this, so why not call it r? And you're going to be m1 because you're tiny, and the Earth is going to be mass 2 because it's huge. Unless you're like a superhero universe size, this is pretty much going to always be true. And they say there's a force of gravity that's created between you with a bunch of these letters that look kind of scary if you don't know what they are. But we don't care what they are because it's not really the problem. And I want to write it like this because I don't like quotients. So I'm going to write it as r to the minus 2 up here. And let's see what they actually want. They say find df dr and explain its meaning. Well, okay. That means all of these are basically constants. We can mostly ignore them. So to find df dr, without doing physics, you can still use a power rule and just do negative 2 g m1 m2 r to the minus 3. Done. We're done with that part. This is the answer. You've been doing power rule every day. This is just in a word problem to try and throw you off a little bit because that's how real life is. It's a word problem. So it says, what does the minus sign indicate? And that's important, right? So if I increase the radius, this whole thing is going to become more negative. And that means that the change in the force becomes less and less the farther away you get. And that should make sense. The farther away from Earth you get, the less you experience its gravity. I hope you would intuitively feel that. It could be hard to interpret numbers that way, but remember, this is all just numbers that are being multiplied and they're ugly, so we use a symbol instead. But basically, if I increase the radius, and don't remember, to the minus 3 does not mean a negative number. It's just a divide by r cubed. If I increase the radius, it creates a more negative number, which means less force than it was before when you were closer. That's what that means. And now they're going to give it to you really easy. Suppose it is known that the Earth attracts an object with a force that decreases at a rate of 2 newtons per kilometer. Well, that's what this is, newtons per kilometer. You have a force and you have a distance. That's the unit, newtons per kilometer. That's what this number is. And they're saying at a rate of 2 newtons per kilometer when the radius is 20,000 kilometers. Well, we know we can put in the radius then, can't we? m1, m2, that's this, which would be 2.0 times 10 to the 4th to the 3rd minus 3rd. I knew something was funny about that. And don't forget that that minus 3 applies in scientific notation to everything in there. So what you're going to get, once I divide negative 2 away like this, we're going to get 1 equals g m1 m2 times 8 times 10 to the negative 12. And so if I multiply both sides by 8 times 10 to the 12th, I'm going to get it on the other side. So we can say g m1 m2 equals 8 times 10 to the 12th. And what we're going to do is we're going to hang on to this truth because they want us to find how fast this force changes at a different radius. Are you going to guess where we're going from here? Let's write our formula. df dr, that's what they're asking you to find now, so we should know the rest. Negative 2, and then gm1 m2, we know what that is. That's 8 times 10 to the 12th times the new distance up here. That's 1 times 10 to the 4th to the negative 3. And that is going to make 10 to the negative 12th, so that would cross that out. And you're going to get df dr equals negative 16 newtons per kilometer. And that means that when you are twice as close to the Earth, you experience 8 times the change in the force of gravity as you move away or toward Earth. That's pretty impressive. What that means is as you're moving away from Earth, very quickly does the force of gravity drop away. Very, very quickly. And that's the answer to this question. So don't focus too much on all the physics. Focus on the formula you're given. Focus on finding the derivative they ask you to, and just try to ignore all the ridiculous lunatic variables they throw into the equation. It's just the way reality is. And derivatives let us focus on one variable at a time this way.